Hey there, space cadets and cosmic curious. Welcome to our celestial circus, where we'll be juggling planets and dancing with orbits. Today, we're demystifying Kepler's third law, the rule that makes the solar system go round and round. Buckle up, because we're about to take a wild ride through the cosmic carnival. Picture this. You're at an amusement park, and you've just hopped on the teacup ride. As you spin, you notice something peculiar. The cups closer to the center are zipping around like they're late for a very important date. Meanwhile, the outer cups are taking a leisurely stroll, as if they're on a Sunday picnic in the park. This, my friends, is Kepler's third law in action, but we'll get to that in a moment. First, let's meet the man behind the cosmic curtain, Johannes Kepler. Born in 1571, this German astronomer was the original space detective. He was so obsessed with celestial mysteries that he probably dreamed in star charts and planetary orbits. Kepler spent years poring over data, trying to crack the code of planetary motion. And let me tell you, this guy had patience that would make a sloth look hyperactive. After years of number crunching and head scratching, Kepler finally had his eureka moment. He discovered not one, not two, but three laws of planetary motion. Today, we're focusing on the third law, which is like the grand finale of a cosmic fireworks show. So what exactly is Kepler's third law? Brace yourselves, because here comes the fancy part. The square of a planet's orbital period is directly proportional to the cube of the semi-major axis of its orbit. Wow! That's a mouthful, isn't it? Don't worry if your brain just did a backflip. We're going to break it down like we're disassembling a cosmic Lego set. Let's start with the orbital period. This is simply how long it takes a planet to complete one lap around the Sun. For Earth, that's 1 year or 365.24 days if you want to be precise. But for other planets, it could be shorter or much, much longer. Now, the semi-major axis is half of the longest diameter of a planet's elliptical orbit. Think of it as the radius of the orbit if it were perfectly circular. It's like measuring from the center of the Sun to the furthest point of the planet's orbit. Here's where it gets interesting. Kepler found that if you take the orbital period, square it, and compare it to the cube of the semi-major axis, you get the same ratio for all planets. It's like a cosmic recipe that works for every planet in the solar system. Let's put this into perspective with a cosmic cooking show. Imagine you're baking planetary cookies. Earth's cookie takes 1 year to bake and has a recipe that calls for 1 cup of flour. Now let's say Jupiter's cookie takes 12 years to bake. According to Kepler's third law, Jupiter's recipe would need 5.2 cups of flour. That's because 12 squared is 144, and 5.2 cubed is about 141. The ratio is nearly the same. This law isn't just a neat party trick for impressing your astronomy-loving friends. It's a powerful tool that helps us understand the architecture of our solar system and beyond. Scientists use it to predict the orbits of newly discovered planets and even to find exoplanets around other stars. But wait, there's more! Kepler's third law doesn't just apply to planets orbiting the Sun. It works for any object orbiting a central mass. Moons around planets? Check. Artificial satellites around Earth? You bet! Even binary star systems follow this cosmic dance. Now let's address the elephant in the room, or should I say, the gas giant in the solar system. You might be wondering, if all planets follow the same law, why don't they all orbit at the same speed? Well, my curious friends, that's where the magic of Kepler's third law really shines. Remember our teacup ride analogy? The closer a planet is to the Sun, the faster it needs to orbit to keep from being pulled in by the Sun's gravity. It's like the inner teacup spinning faster to avoid falling into the center. Meanwhile, the outer planets are taking their sweet time, like those leisurely outer teacups. Let's take a look at some examples to really drive this home. Mercury, the speed demon of our solar system, zips around the Sun in just 88 days. It's like that one friend who always power walks through the mall while you're trying to window shop. Earth, as we know, takes a year to complete its orbit. And then there's Neptune, the laid-back surfer dude of planets, taking a whopping 165 years to make one trip around the Sun. Talk about a long-term commitment. But here's the kicker. Despite these vastly different orbital periods, they all obey Kepler's third law. It's like they're all dancing to the same cosmic tune, just at different tempos. Now you might be thinking, this is all well and good for planets, but what does it mean for me? Well, my Earthbound friend, Kepler's third law has some pretty cool applications right here on our home planet. For starters, it helps us put satellites into orbit. Whether it's for communication, weather forecasting, or binge-watching your favorite shows, satellites need to be placed at just the right distance to orbit Earth at the correct speed. Too close, and they'll zoom around too fast and eventually crash. Too far, and they'll drift away into space, never to be seen again. Kepler's third law helps engineers find that Goldilocks zone for satellite orbits. But wait, there's more! This law also helps us in the search for exoplanets, planets orbiting other stars. By observing how a star wobbles or dims periodically, scientists can use Kepler's third law to calculate the orbit and even the mass of planets we can't directly see. It's like being a cosmic detective, solving mysteries across light years of space. And for all you sci-fi fans out there, Kepler's third law is essential for planning hypothetical space colonies. Want to build a floating city around Jupiter? You'd better brush up on your Keplerian mechanics. Otherwise, your space station might end up taking an unexpected detour into the Great Red Spot. As we wrap up our cosmic journey, let's take a moment to appreciate the elegance of Kepler's third law. In a universe that often seems chaotic and unpredictable, here's a simple relationship that governs the motion of everything from tiny moons to massive planets. It's a reminder that underneath the complexity of the cosmos, there are beautiful, fundamental principles at work. So the next time you look up at the night sky, remember that you're witnessing Kepler's third law in action. Those twinkling points of light are all dancing to the same cosmic rhythm, a waltz written in the language of mathematics. And who knows, maybe someday, armed with this knowledge, you'll be the one to discover the next Earth-like planet or design the first interplanetary cruise line. Until then, keep looking up, stay curious, and remember, in the grand dance of the cosmos, we're all just following Kepler's lead. And that's a wrap on Kepler's third law. Thanks for joining us on this cosmic adventure. Don't forget to like, comment, and subscribe for more out-of-this-world science. Until next time, keep orbiting awesomeness.